Good morning students. Last class we discussed about real numbers, complex numbers and some properties of complex numbers. So in this class we are going to discuss some problems on complex numbers. So before that, just know about powers of I. Okay. So powers of I, we know that I value must be equal to root of minus 1. So next consider I square means root of minus 1, I is equal to root of minus 1. So root of minus 1 square and square root get cancelled, I square value is equal to minus 1. Next consider I cube. So I cube can be written as I square into I. So we know that I square value is minus 1. Minus 1 into I, this equal to minus I. Next, I to the power of 4. Okay, I to the power of 4 can be written as I cube into I. I cube into I to the power of 4. I cube value is minus 1. Minus 1 into I. Minus I into I square. Okay, minus, we know that I square value is minus 1. So minus of minus 1 is plus 1. Okay, next consider I to the power of 5. I to the power of 5 can be written as I to the power of 4 into I. I to the power of 4 value is 1 into I. So 1 into I. Okay, next consider I to the power of 6. I to the power of 6 can be written as I to the power of 5 into I. I to the power of 5 value I into I as it is. I into I square. I square value is minus 1. So I to the power of 6 value minus 1. Next, I to the power of 7. This can be written as I to the power of 6 into I, or I to the power of 4 into I to the power of 3. I to the power of 4 into I to the power of 3 is also a 7. Okay, I consider here I to the power of 6 into I. I to the power of 6 value minus 1 into I. So minus 1 into I minus I. So consider next number I to the power of 8. This can be written as I to the power of 7 into I. I to the power of 7 value minus I into I into minus I into I square. I square value minus 1. So minus of minus 1 plus 1. So on. So here observe I to the power of I value is root of minus 1, I square is minus 1, I cube is minus I to the power of 4. Here observe I to the power of 4 value is equal to 1. I to the power of 8 value is also equal to 1. So suppose if you find the value of I to the power of 12, I to the power of 12 is also equal to 1. I to the power of 16, I to the power of 16 is also equal to 1, means, so generalize. So if the power of I is multiple of 4, if the power of I is multiple of 4 means in general multiple of 4 is denoted by 4 into k. K is any integer. If you consider 1, 4 into 1, 4. Next, if you consider 2, 4 into 2, 8. Means power is a multiple of 4. Then the value must be equal to 1. If the power of I is multiple of 4, then the value is equal to 1. Next, here observe power is 4 plus 1. So multiple of 4 plus 1. Here, suppose next consider I to the power of 9. I to the power of 9 can be written as I to the power of 8 into I. I to the power of 8 value 1 into I is equal to I. So here 9 can be written as 8 plus 1 multiple of 4 plus 1. 8 is a multiple of 4. Multiple of 4 plus 1, then the value is equal to I. Then the value is equal to I. So in general, power of I is multiple of 4. 4 into k means multiple of 4 plus 1. Then value is equal to I. Okay. Next, here I to the power of 6, I to the power of 6 can be written as multiple of 4 means 4 plus we want C, so 4 plus 2. So power of I is multiple of 4 plus 2, then the value is equal to minus 1. We can find the value of I to the power of 13. Sorry, I to the power of 14 value is also equal to minus 1. Multiple of 4 means this can be written as 12 plus 2, 14. So multiple of 4 plus 2 value is equal to minus 1. Therefore in general I to the power of 4k plus 2 is equal to minus 1. So next 4k plus power of I is 4k plus 3. 4k plus 3. Here 4 plus 3 is equal to minus. In general, power of I is multiple of 4 plus 3, and the value will be equal to minus I. Suppose if we consider 4k plus 4 means again it is a multiple of 4. Again we get a value 1. Okay. In general, if the power of I is multiple of 4, then the value will be equal to 1. If the power is multiple of 4 plus 1, then the value will be equal to I. So power of I is multiple of 4 plus 2, then the value will be equal to minus 1. If the power is multiple of 4 plus 3, then the value will be equal to minus I. Suppose consider, directly find out value of I to the power of 8. So 8 is a multiple of 4, therefore value is equal to 1. I to the power of 12 is also equal to 1. I to the power of 16 is also equal to 1. I to the power of 40. 40 is a multiple of 4, 4 into 10. Therefore, it is also equal to 1. Suppose find the value of I to the power of 16. Okay, we want I to the power of 15. So here first represent here I to the power of 15 multiple of 4 plus some term I to the power of 15 can be written as we want multiple of 4. So 12 is a multiple of 4. So 15 can be written as I to the 12 plus 3. This can be split as I to the power of 12 into I to the power of 3. Okay. So I to the power of 12 into I to the power of 3. So we know that I to the power of 12 is power is multiple of 4, therefore value is equal to 1. Then I cube value is minus I. So therefore 1 into minus I here multiple of power is multiple of 4 plus 3, then the value is equal to minus I. And the value is equal to minus I. Okay. Now let us discuss some problems. Evaluate the following and write the real and imaginary part. Okay. First problem, 1 plus I plus 2 plus 3 into I. Okay. Evaluate means first represent given complex number in the form of A plus I into B, and then find the real part and imaginary part. So first simplify. So denote it by Z. So simplify means here we have addition symbol. So 1 plus I plus into 2 plus 2 plus into 3I plus 3I. Here 1 plus 2 3 plus 1I plus 3I. 1I plus 3I is 4I. This is in the form of A plus I into B. There implies real part of Z. Real part of Z is 3. Imaginary part of the complex number is plus 4. Imaginary part is plus 4. Okay. Next problem, second one. 2 minus I minus of 6 plus 3i. Okay, first simplify and then represent in the form of a plus I into b. So simplify. 2 minus I minus into 6 minus into plus minus into 3i minus 3i. 2 minus 6 is minus 4 minus 1i minus 3i, that is minus 4i. This is in the form of a plus I into b. Therefore, real part of the complex number is minus 4. Imaginary part of the complex number coefficient of I is minus 4. Okay, real part is minus 4. Imaginary part is also equal to minus 4. Next problem, third one. Next problem, third one. 1 plus I into 1 minus I. So first represent given complex number in the form of a plus I into b. So multiply these two terms. First multiply this term by 1. 1 into 1, 1. 1 into minus I, minus I. Next multiply this term by plus I. Plus I into 1, plus I. Plus into minus, minus. I into I square. So 1 minus I plus I get cancels. Minus I square value minus 1, 1 minus of minus 1 plus 1, 1 plus 1, 2. So therefore z is equal to 2. So purely real part, therefore real part of given complex number is 2. So okay, imaginary part is 0, independent of I. Therefore imaginary part is, real part is 2, imaginary part is 0. Okay, next problem. Fourth one, minus 1 plus 5i divided by 2. So first represent given complex number in the form of a plus I into b, means real part plus real number plus I into real number. Here observe, denominator we have real number, so directly split into each term. So this can be written as minus 1 by 2 plus 5 by 2 into 5i by 2 or 5 by 2 into I. So this in the form of real number plus I into real number. Minus 1 by 2 is also a real number, 5 by 2 is also a real number. Therefore this is a complex number. Therefore real part is minus 1 by 2. Minus 1 by 2, 5 by 2 are real numbers. Minus 1 by 2 is real part, 5 by 2 is called imaginary part, coefficient of I. Therefore imaginary part of the complex number is 5 by 2. So 5 by 2 is called the imaginary part. Okay. Next problem. Fifth one, 1 plus 2i divided by 3 minus 4i. Okay. First here observe, first we want to represent this given complex number in the form of a plus I into b, means in the form of real number plus I into real number. Suppose if we split denominator to each term, we get 1 by 3 minus 4i plus 2i divided by 3 minus 4i. But here observe, 3 minus 4i is not a real number. Having I term means it is a complex number, a very real number. Real number, next number system is complex number. Complex number including real number. Every real number is a complex number, but every complex number need not be a real number. Okay. Therefore, complex number is not a real number. Therefore, first rationalize the denominator. 1 plus 2i divided by 3 minus 4i. So, rationalize the denominator. So, multiply and divide by 3 minus 4i. So, multiply and divide by 3 plus 4i. To represent in the form of real number plus I into real number. So, multiply and divide by 3 plus 4i. Next, simplify. 1 plus 2i into 3 plus 4i. 1 plus 2i into 3 plus 4i divided by 3 minus 4i into 3 plus 4i. 3 plus 4i. So, multiply this term by 1. 1 into 3, 3 plus 1 into 4i, 4i. Next, multiply this term by 2i. 2i into 3, 2 into 3, 6, 6i plus 2i into 4i. 2 into 4, 8. I into I square, 8 I square. I square value is minus 1. Okay. O thing divided by, here observe this is in the form of a minus b into a plus b. So, therefore, this can be written as a square. A plus b into a minus b is a square minus b square. This can be written as 3 square minus b square. A minus b. A value 3 minus b. B value 4i. b square means 4i whole square. So, 3 plus 4i plus 6i. 10i plus into minus minus 8 into 1, 8. Whole thing divided by 3 square is 9 minus 4 into, 4 square. 4 square is 16 into I square. I square value is minus 1. So, 3 minus 8 is minus 5 plus 10i divided by 9 plus minus 16 into 1. Minus 16 into minus 1 plus 16. So, this can be written as minus 5 plus 10i divided by 9 plus 16, 25. So, now we get real number. 25 is a real number. Now, split the denominator to each term. This can be written as minus 5 divided by 25. Minus 5 by 25 plus 10i by 25. Simplify. 5 1 the 5 5 the 5 2 the 5 5 the. So, minus 1 by 5 plus 2i by 5. So, now this is in the form of real number plus I into real number. Therefore, real part is called minus 1 by 5. Imaginary part is equal to coefficient of I is 2 by 5. So, real part is minus 1 by 5. Imaginary part is 2 by 5. So, next concept is modulus of a complex number. Now, let us discuss a new concept, modulus of a complex number and conjugate of a complex number. Next concept is modulus of a complex number. So, consider a complex number, it must be in the form of a plus I into p. Modulus of the complex number is denoted by the symbol, read as modulus of z, defined as square root of a square plus b square. So this is the definition for modulus of a complex number. For example, consider 3 plus 4a complex number. Modulus of this complex number is square root of a means real part. A value 3 square plus b value 4 square. So 3 square is 9, 4 square is 16, root of 16 plus 9, 25, root 25 is 5. Therefore, modulus of complex number 3 plus 4i is 5. This is called modulus of the complex number, denoted by the symbol defined as square root of a square plus b square. Next, last concept, conjugate of a complex number. For the complex number a plus I into b, conjugate is denoted by z bar, defined as a minus I into b. Means here change the sign of the imaginary part. Here imaginary part is plus b, only change the sign of imaginary part. For example, consider 2 plus 3i. For this complex number, conjugate is, write 2 as it is, change the sign of imaginary part. Here imaginary part is plus 3 becomes minus 3. So for the conjugate of 2 plus 3i is 2 minus 3i. Suppose consider minus 2 plus 3i. Here also write real part as it is, write minus 2 as it is, only change the sign of imaginary part. This plus 3i becomes minus 3i. Now consider minus 2 minus 3i. So conjugate is minus 2, write real part as it is, minus 3i becomes plus 3i. So this is the conjugate for the given complex numbers. Next, let us discuss some problems. First one, if z is equal to 3 minus 4i whole square, then find z bar. Okay, then find z bar. Given that z is equal to 3 minus 4i square, z bar means we want to find out conjugate. Means first represent given complex number in the form of a plus ib. So first simplify here. Represent in the form of a plus ib. But here we have a plus ib whole square. So first expand. So by applying a minus b whole square formula, a minus b whole square is a square means 3 square plus b square means 4i whole square, a square plus b square minus 2ab. A means here 3, b means 4i. So 3 square is 9, 4 square is 16 into I square. I square value is minus 1 minus 2 into 3, 6 into 4, 24 into I. So 9 plus into minus minus, 16 into 1, 16 minus 24i. So 9 minus 16 minus 7 minus 24i. So now given complex number in the form of a plus I into b, a value minus 7, b value minus 24. Now find out, we want z bar conjugate. Z bar is equal to, write real part as it is, minus 7, change only sign of imaginary part. So minus 24 becomes plus 24i. Therefore conjugate of the given complex number 3 minus 4i whole square is minus 7 plus 24i. Okay. Next, last problem. if z is equal to 4 minus 3i, then find 1 by z. Okay, so given that z is equal to 4 minus 3y, we want 1 by z. 1 by z means 4 minus 3i. So now represent 1 by z is also a complex number represent in the form of a plus ib. So rationalize the denominator. So 1 minus 3i. So multiply by 4 plus 3i. So 4 plus 3i. So multiply 4 plus 1 into 4 plus 3i. 4 plus 3i divided by 4 minus 3i into 4 plus 3i. This is in the form of a minus b into a plus b. A square means 4 square minus b square means 3i whole square. So therefore 1 by z is equal to 4 plus 3i divided by 4 square is 16 minus 3 square is 9 into I square value minus 1. So 4 plus 3i divided by 16 minus 9 into minus 1 plus 9. So 4 plus 3i divided by 16 plus 9, 25. Therefore 1 by z is equal to real number. So split the denominator to each term. 4 by 25 plus 3 by 25 into I. So therefore 1 by z is equal to 4 by 25 plus 3 by 25 into I. Okay, this chapter is completed. Okay, we will continue next class in next chapter. Thank you.